My dear students and younger friends, ACE Engineering Academy welcomes you. In previous session, we have completed preparation strategy. Right now, we are going to discuss important concept. This is V Ramaiah, faculty of ACE Engineering Academy. Important concepts for both CS and IT gate aspirants. This session is aimed to only CS and IT branch students. Let us start. First one. It belongs to first topic, computer arithmetic, sign bit extension. Actually, it is the common topic between digital logic subject and our COA subject. At the same time, without having clarity in this, not possible to understand the so many subtopics in the first one. That's why sign bit extension, this technique is used to convert smaller size signed data to larger size. By padding the sign bit to left. By padding the sign bit to left. -8 means -6. It is a decimal value. When this data is in signed to 2's complement notation. Now, if you want to change the data from 4-bit to 6-bit, there is no change in this. The additional bits are nothing but sign bit extension means the sign bit is extended to left. For how many positions? There is no limitation. Now, this data size is 6-bit. At the same time, its decimal value is also same. 1, 2, 4, 8, 16, -32. MSB weight sign is negative while finding the decimal value for the given data when it is in signed to 2's complement notation. Its value also -6. It is nothing but sign bit extension. Whatever the MSB is used to represent sign bit. Whatever the MSB, it can be 0 or 1. That bit is shifted to left. It is nothing but sign bit extension. Next, overflow. It is very important concept. Overflow concept is very important concept. At the same time, here we are going to discuss one point clearly. Suppose C in and C out are given. Then what about the technique used to detect occurrence of overflow? Inputs of XOR gates are nothing but C in and C out. If output is 0, means no overflow. Output is 1, overflow occurs. Okay, now sometimes question will be given like this. X is the sign bit in first data. Y is the sign bit in second data. Z is the sign bit in the result. It is the sign bit in first data, sign bit in second data, sign bit in the result, means MSB in the result, but these are not belonging to C in, C out. Then what is the procedure to detect overflow? Means what is the expression for computing the overflow detection? In this, overflow does not occur after adding one positive data and one negative data. Overflow may occur after adding 2 number of positive data or 2 number of negative data at the same time. O means positive. Then also overflow occurs. Overflow occurs either in this case or in this case. Plus means here R symbol. Third case is also there. Data will be given. Data will be given. For which type of these data combinations overflow will occur. This type of question was given in 2022. For this, very simple and very clear. When data size is suppose 4-bit, First, perform addition between these two data. When the data decimal value is between -8 and +7, when each data size is 4 bit, overflow does not occur. Otherwise, overflow occurs. Let the data size is n bit. Look here. Let each data size is n bit. The overflow occurs. The overflow occurs when result is not available in the range of -2 power n minus 1 to plus 2 power n minus 1 whole minus 1. What is n? Size of each data. Let n is equal to 8. The overflow does not occur when the result is between -128 and plus 127. When result is between -128 and plus 127, after adding two number of 8-bit data, overflow does not occur. Overflow occurs when the result is less than -128 or more than or greater than plus 127. These three concepts are sufficient to solve overflow. Question on overflow. Overflow is very, very, very important concept. Next, in first chapter, Booth's algorithm is there. In this, what is the procedure to find Booth's code? Booth's code for suppose -25. It is decimal value. First, find its 2's complement notation. -25 means its closest to smallest negative value is -32, 16, 8, 4, 2, 1. Here -32 plus 7 minus 25. Now, how to generate Booth code for this? For generating Booth's code, right, like this 1, 0, 0, 1, 1, 1. You take one special bit. Always that special bit is 0. Scan successive bits. Scanning will be started from LSB onwards. Here both are different. Then operation is required. Which type of operation? The shifted multiplicand is added for +1 or -1 times. Here right side 0, left side 1 means -1 times. Next, both are same, nothing. Both are same, nothing. Here different means shifted multiplicand is added for +1 times, same, -1 times. Now it is the Booth's code. If you have any doubt in this answer, self-test is there. It is the Booth's code for -25 means 1, 2, 4, 8, 16, 32. Here -32 plus 8 means -24, -1, -25. This technique is more useful. Next, IEEE standard used for floating point representation. Generally, there are two methods. 32-bit is there, 64-bit is there. Earlier, there were no gate questions on the 64-bit. We had so many number of times questions on only 32-bit. In 2022 paper also, we had 2 mark question. For this, simply look here. Now, it is divided into 3 fields. Total size is 32-bit. In this, MSB sign bit, it is nothing but biased exponent. E biased exponent, it is nothing but mantissa. mantissa is represented in signed magnitude form. It is biased exponent. What is capital E? Nothing but small e plus b. What about small e? True exponent. What is b? Biasing value. Here biasing value is fixed, 127. Mantissa is expressed in signed magnitude form only. What about this S? Sign bit. S is 0 for positive data. When mantissa is positive, 0, otherwise 1. Okay. Next, what about the expression value? Expression value. In this, -1 whole power S into 1 point M. This one is nothing but hidden bit into 2 power capital E minus 127. What is capital E? Biased exponent. It is unsigned exponent. In this, what is capital E minimum? Capital E minimum is equal to 0 because its size is 8 bit, signed bit size is 1 and its size is 23 bit. What about capital E maximum value? 255. In this, E minimum and E maximum values are reserved for special values. Those are nothing but plus or minus 0, plus or minus infinitive and not a number. Okay. Now, we are going to discuss one question on the same. Look here. Question is like this. This question was given in IT gate paper and ISRO. There was separate gate paper for IT branch from 2004 to 2008. From 2009 onwards, we are getting same. Now, C1D0, it is represented in IEEE single precision. IEEE single precision means 32-bit. Single precision is also known as 32-bit. He asked the decimal value of the same. What about decimal value? It is the question. It is the question. Then what is the procedure to solve the question? Immediately, C means find the binary value, 12, 1. Each hexadecimal digit is directly represented with 4-bit. D means 1101, remaining all are zeros. What about this? Sign bit means value is negative. 1, 2, 3, 4, 5, 6, 7, 8. What about this? Capital E value, its value is 131, means small e value is equal to 4 because biasing value is equal to 127, nothing but mantissa. Then according to expression value, look here. Already I told expression value. From this, look here. -1 whole power S means minus. Next, 1.1010 remaining all are zeros into 2 power 4. When it is 0, then what happens? Not needed to compute this value. That's why to get a 0 here, you have to shift the decimal point right. For how many positions? 4 positions. Then not needed to consider. Then what about this value? Now it is in binary. 1, 2, 4, 8, 16 means minus 26. Answer is minus 26. Okay. Next. Come to second one, memory space definition. It is very, very, very important. Memory space. So many students feel memory space means it is storage device. Yes, but what is the primary definition? Storage device is secondary definition. What is primary definition? Workspace. Workspace, working area, or working ground. In this, what about definition here? Number of memory registers into capacity of one register. Number of memory registers, REGS registers into capacity of one register. One memory register is also known as one memory location, one memory word, and one memory pocket. And special definition is also there. What is the special definition for memory space? Number of rows into number of columns. It is very, very, very important. What about special definition? Number of rows into number of columns. Okay. Next. What is average memory access time? In two-level memory, means only two memory levels are there. Let first one is L1, second one is L2. H represents hit rate, M is nothing but miss. Now in this case, T represents access time of the memory module. In this, in two-level memory, means two levelings are there. L1 represents first level, L2 represents second level. In this, what about AMET expression? In two-level memory, AMET expression is nothing but H1 T1 plus 1 minus H1 into T2. What is T1? Word access time from L1 memory. H1, hit rate in L1. Next, T2, word access time in L2 memory. It is applicable for parallel connection. Means when memory modules are connected in parallel, means processor will get the data from L1 memory and L2 memory simultaneously. Means sequence operation is not there. But sometimes if you are asked the question in serial manner, means serial connection means always words are supplied by L1 memory only. In that case, what is the procedure? H1, T1, there is no second doubt, plus 1 minus H1 into T2 later, plus T1, because first word is supplied from L2 to L1, then only from L1 memory to processor. That's why it is also needed to add. It is for serial connection. Suppose type of connection is not given, question is given, type of connection is not given, in default parallel connection. Next, physical address format. What is physical address format? Main memory address is nothing but physical address. Main memory. Word address is known as physical address, because main memory is also known as physical memory. What is the procedure to divide physical address in different fields? Here, there are three types of mapping techniques: direct mapped cache, block set associative mapped cache, fully associative mapped cache. In this, first of all, watch this. Main memory word address is also known as physical address. What does it mean? Number of bits required for addressing a word from main memory is nothing but physical address. Let it is direct mapped cache. Look here. In direct mapped cache, physical address format is like this. It is divided in three fields. What about the name of these fields? Tag, Here it is nothing but line offset. Cache block is also known as cache line, nothing but word offset. How to compute these fields? Here, total address is nothing but physical address. In this, what is the procedure to find line offset? Nothing but log CL with base 2. What is CL? Number of cache lines in cache memory. Next, what is word offset? Log BW. What does it mean? Number of words in one block. Remaining one is nothing but a tag. Remaining one is nothing but tag. Suppose, first of all, first compute this one, next compute this one, next add these two, subtract that one from physical address at the same time. When size of the physical address and size of the cache address are given, then what is the procedure for finding the tag field size? Tag size is equal to PA minus CA. Okay. Sometimes number of blocks in main memory and number of blocks in cache memory will be given. These are applicable for direct mapped cache. It is also equal to log MB by CL. What is MB? Number of blocks in main memory. What is CL? Number of blocks in cache memory. Number of lines in cache memory. One line is also known as one block. Okay? Next. Next, block set associative mapped cache. Same, suppose it is block set associative, then what about this tag field? What about this set offset? What about next one, word offset? In this, what is the size of this? Same physical address. Then what is the procedure? All things are same, but here log BW means number of bits required to select one of the words in the selected block. Here log S. What is S? Number of sets. How you compute this S? S is nothing but CL by N. What is N? Associativity. In four-way block set associative, each set has 4 blocks like that. Here S is nothing but how you compute S? Number of cache lines by associativity, later tag. In this, what about tag field size? It is very, very, very important concept because we had questions on this so many number of times. Tag field size is nothing but, already we computed the tag field size for direct mapped cache, means PA minus CA plus log N. What is N? Associativity. Associativity. When number of blocks in main memory and number of blocks in cache memory are given with associativity, then look here, log MB by CL. This one gives the tag field size for only direct mapped cache plus log N, associativity. We use this expression when number of blocks in main memory and number of blocks in cache memory are given. We use this one when size of the physical address and size of the cache address parameters are given. Okay. Next, what about next one? Fully associative mapped cache. In this, look here. Let it is physical address. Let it is physical address. It has only 2 fields. First one, what about this? Tag. What about this? Word offset. In this, cache index field is not required. Then what is the procedure to find tag field size? Tag field size means number of bits required in tag. Nothing but PA minus log BW. What this one tells? It is nothing but log BW. What does it mean? This field tells number of bits required to select one of the words in the selected block. PA minus this size directly gives the tag. Okay? Next. Tag directory computation. It is very, very, very important. In this, be dedicated, very, very, very important. Whatever the mapping technique, means whether it is direct mapped cache, block set associative, or fully associative, whatever the type of mapping technique, how to find the tag directory size? In this, T into CL only. What is a T? Number of bits in tag field of the given physical address format. What is PA format? Physical address format. Number of bits in the tag field of the given physical address format. What about CL? Number of cache lines. Whatever the type of mapping technique doesn't matter. It is the universal expression because one separate tag field is required for each cache line. One separate tag field is required for each cache line. That's why. What is the procedure for finding the total tag directory? Tag directory means collection of all tag fields, nothing but a T into CL. It is the universal expression, whatever the mapping technique used. Already I explained the reason. Each cache line requires separate tag information, whether it is direct mapped cache, block set associative mapped cache, or fully associative mapped cache. Next, block replacement algorithms. When miss has occurred in cache memory, processor visits main memory. Then, when all blocks are filled in cache memory or when in certain set, no vacancy is there, then it uses replacement algorithm for selecting the one of the blocks to be replaced. These techniques are nothing but block replacement algorithms. In operating system, it is also known as page replacement algorithms. In this, in our subject, we are going to discuss FIFO, first in and first out. Next, LRU. Next, optimal. In FIFO technique, the block means block number, which is arrived first, it is selected for replacement. Means a block which is available in the cache memory from longest time will be selected for replacement. In LRU technique, whatever its arrival time doesn't matter. A block which is not referenced by the processor from longest time will be selected for the replacement. In optimal, it checks the future needs. The block which is not required in near future will be selected for replacement. Next, different misses to be occurred while executing a program. While executing a program, what about the different misses faced by the processor? These are nothing but, first one, compulsory miss. It is also known as cold miss. Second one, capacity miss. Third one, conflict miss. What is compulsory miss? When any block is mapped first time from main memory to cache memory, it is compulsory, also known as cold miss. So compulsory miss is occurred in all mapping techniques at the same time. What is capacity miss? When all blocks in cache memory are filled, then only capacity miss occurs. Generally, it is occurred in fully associative mapped cache. In rare cases, it is occurred in others. Now, when all blocks in cache memory are filled, then only capacity miss occurs. At the same time, we can express the same in another way. When program length is larger than the cache memory size, when program to be executed program length is larger than the cache memory size, then capacity miss occurs. What is conflict miss? It is neither compulsory nor capacity simply. Neither compulsory nor capacity. Means when block is not found, when target block is not found in cache memory and a processor references the same first time, it is compulsory. Second time means after mapping a block from main memory to cache memory, processor executes the same. In future, for mapping one more block in the same position, processor may evict that block, evict means replace that block, and at the same time, again and again, processor may require that block services in future. Then from second time onwards, that miss is nothing but conflict miss. First time, only compulsory miss. These are very, very, very important. Next, address format in a magnetic hard disk. In magnetic hard disk, what is the address format? Now in this, look here. First of all, magnetic hard disk is the collection of surfaces. First of all, surface offset. Means when hard disk is having 16 surfaces, it requires 4 bits. Now it is nothing but total address, word address or byte address. Now in this, log H, what H tells? Number of heads, because one head is required for one surface. Number of heads is nothing but number of surfaces. It tells the particular surface number. Next, later, surface is the collection of tracks. That's why next, track offset. Now, log T. What is T? Number of tracks in one surface. Next, track is the collection of sectors, means sector offset. Means log S. What S tells? Number of sectors in one track. Next, sector is the collection of bytes, means byte offset. Means log B. What B tells? Number of bytes in one sector. It is the procedure. Okay. Sum of all these parameters is nothing but the address of a byte in entire hard disk. At the same time, what is the storage capacity expression in hard disk? Storage capacity expression in hard disk is like this. Storage means data storage. Nothing but H into T into S into B. Here, first you find T into S into B. What is B? Number of bytes in one sector. What is S? Number of sectors in one track. What is T? Number of tracks in one surface. What is H? Number of surfaces in hard disk. Means these three means, look here, this computation provides the one surface capacity into number of surfaces. Next, logical cylinder. In magnetic hard disk, it is very important. What is logical cylinder? Get 100% clarity in this, otherwise not possible to solve a question from logical cylinder. We had excellent questions on this. It is the, cylinder is the collection of all tracks in the relative position, same relative position of, in the same relative position from all surfaces. Simply, suppose four surfaces are there. Surface is the collection of tracks. In first surface, T0, T1, T2, T3, T means tracks. Second surface, in second surface also T0, T1, T2 like that. In third surface, same. Fourth surface also same. Collection of all T0 means track number 0, nothing but C0. Collection of all T1s, nothing but C1. Finally, collection of all Tn number, Tn means nth track number, tracks is known as Cn. What is Cn? Cylinder number n. Okay. Next, instruction set supported by the basic processor. Basic processor instruction set. This instruction set is divided in two categories. That depends on the operation to be performed, and size of the code means opcode. In this, that depends on the operation to be performed. Instruction set classification is like this: data transfer instructions, arithmetical instructions, logical instructions, branch instructions, machine control instructions. These are depending on the type of operation to be performed at the same time. Instruction set classification that depends on the size of the opcode, means number of address fields used, nothing but. It is very important. 3 address instructions. 3 address instructions means instruction is filled with 3 address fields. Next, 2 address instructions. Next, 1 address instruction. Finally, 0 address instructions. Okay, it is the classification. Next, addressing mode. What is addressing mode? It is very, very, very important. Way of locating the operand that is to know the address of the operand. Address of the operand is nothing but effective address. Addressing modes are basically divided in two ways. What is first one? Non-computable addressing modes. AM means addressing mode. Next, computable addressing mode. In this, look here, I am going to express most important point. Question is given. Question is given. He asked to find the type of addressing mode. Let it is MCQ, multiple choice question. 4 options will be there. Then what is the procedure to find the target answer in shortest time? First you come to know whether it is computable or non-computable. In non-computable addressing modes, effective address is generated directly, computation is not required. But in computable addressing modes, effective address is generated after computation. What about examples for non-computable? Implicit addressing mode, immediate addressing mode, memory direct addressing mode, memory indirect addressing mode, register addressing mode, register indirect addressing mode. Just this. Next, what are computable addressing modes? Base register addressing mode, index register addressing mode, based and indexed addressing mode, PC relative addressing mode, scaled addressing mode. Okay. Next, in these, very, 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 very important one is PC relative addressing mode. It is very, very, very important. Only in this addressing mode, the displacement given in the instruction, the displacement which is given in the instruction is added to the PC content. PC means program counter. Why? To generate the effective address. EA means effective address. Generally, this addressing mode is used for reducing the opcode size, means it is used in the place of short jumps. It is used in the place of short jump instructions. What is short jump instructions? What is long jump instruction? Short jump instruction means when the difference between present PC content and target instruction address is less than or equal to least 8 bit in the given address, then it is short jump. Otherwise, it is long jump. What is forward jump and what is backward jump? When program execution sequence goes forward after executing a branch instruction, then it is known as forward branch instruction, simply forward jump instruction. When program execution sequence goes backside, means earlier instructions, then it is nothing but backward jump instruction. PC relative addressing mode can be used for both forward and backward jump instructions. It can be used for both forward and backward jump instructions. Next. What is stack memory and stack pointer? Stack memory is the common memory between processor and user. Stack memory can be addressed by either processor or user. Processor uses stack memory services for storing the return address when interrupt has occurred. Next, what is stack pointer? It is the address managing register for stack memory while executing push and pop instructions, push R and pop R instruction. Push R, what does it mean? It is used to, pushing means writing, write R content. On stack. Stack memory is simply known as stack. Pop R, it is used to read stack content to the specified register. Here that specified register is nothing but R. What R tells? Register. Generally we use register number R1, R2, R3 like that. While executing push R and pop R instructions, SP provides the stack memory address. Because of that reason, SP is the address managing register. SP is the stack pointer. It is available in processor. It is the address managing register. Is the address managing register for stack. You remember one point clearly. Push operation. Push instruction is used to perform writing operation. Pop instruction is used to perform reading operation. For addressing stack memory, only these two instructions are used. Next, pipeline. Processor can be designed in so many techniques. Non-pipeline technique, pipeline technique. In pipeline technique, it can be arithmetical pipeline or instruction pipeline. Arithmetical pipeline processor is used to perform arithmetical operations. Generally, it is used for vector algebra computation. Instruction pipeline processor is used for executing a program. It is costliest. Why it is costliest? This one requires more number of ALUs, more number of ALU, arithmetical and logical units. These are costlier. That's why this concept is used only in super fast computers. Most of the advanced systems, means in real-time applications, instruction pipeline is used. In instruction pipeline, instruction cycle is divided into, instruction cycle is divided into sub-operations. Those are nothing but instruction fetch, instruction decode, operand fetch. It is also known as data reading. Operand fetch is also known as data reading. Next, perform operation, also known as execute. Next, write back. In this, entire instruction cycle is divided into number of sub-operations like this. It is not so costliest like arithmetical pipeline. That's why most of the general purpose systems are designed with this one. Next, what is speed up? Nothing but Tn by Tp means while executing a program, first find the amount of time needed to execute that program on non-pipeline processor. Tn means amount of time needed to execute a program on non-pipelined processor. N, non-pipelined processor time. P, pipeline processor time. What about the maximum speed up? Always maximum speed up is less than or equal to K. What is K? number of segments, also known as stages. Next, pipeline conflicts. Means while executing a program, processor may face some difficulties. Those difficulties, difficulty is general word. Those difficulties are nothing but conflicts, hazards. These are also known as hazards. Those are nothing but occurrence of conflict degrades the system performance. Occurrence of conflict degrades the system performance. Means some number of clock cycles are wasted. Means some number of clock cycles are wasted means it is closerly moved towards to the non-pipeline. That's why occurrence of conflict degrades the system performance because some number of clock cycles are wasted for resolving the difficulty. Next, different difficulties are like this. Difficulty means conflict, resource conflict. It occurs when sufficient resources are not available. In arithmetical pipeline, resource is nothing but number of ALUs. In instruction pipeline, it occurs when program and data are stored in single memory module. To resolve this, in arithmetical pipeline, more number of ALUs are needed to design. In instruction pipeline, it is resolved by utilizing the separate memory modules for storing the program and data, known as program memory and data memory. Technically, program memory and data memory. Simply, generally, L1 memory and L2 memory, level 1 memory and level 2 memory. Cache memory is available in L1, L2 like that. Next. What about next one? Data dependency conflict. It occurs. It occurs when current executing instruction depends on the result of its surrounding instructions. Its surrounding instructions and result is not available. If result is available, then this conflict does not occur. It occurs when current executing instruction depends on the result of its surrounding instructions and the result is not yet available. To resolve this, operand forwarding technique is best method. It is costliest, but target operand is directly supplied from the external source. Next, branch conflict. It occurs while executing conditional branch instructions. It occurs while executing conditional branch instructions. To resolve this, to resolve branch conflict, branch prediction technique is used. Branch prediction technique is used to resolve this. Conflict is also known as hazard. Next, control unit. It is not so important topic like earlier, but I am going to utilize 5 minutes time for completing control unit and IO organization. Here, control unit can be designed in two techniques, hardwired control unit and microprogrammed control unit. What about hardwired control unit characteristics? In this, complex hardware logic circuit is used. That's why it is costliest. But what about merit of this one? Fastest, because control memory is not required. For generating control signal, control memory visit is not required. No control memory visit. That's why it is fastest. These are the important characteristics. What about demerit? Costliest. What about merit? Fastest. That's why it is used in RISC processor, reduced instruction set computer. Next, what about microprogrammed control unit characteristics? In this, control memory is used to store control words. Control memory is used to store control words. Means minimum hardware circuit is sufficient. That's why it is cheaper or cheapest. But it requires control memory visit. That's why it is slowest. Where it is used? It is used in CSE processor. What is RISC? Reduced instruction set computer. Means minimum number of instructions are used in this, because in this speed is very, very, very important parameter. Speed is essential parameter. What about the number of instructions here? 30 to 40 only. What about number of addressing modes? Maximum 5 only. Number of addressing modes, maximum 5. Then effective address computation becomes easy. Effective address computation becomes easy. That's why it is fastest. But it is not suitable for most of the real-time applications. Generally, it is used in digital signal processing application, because where speed is essential parameter, and because of its fastest nature, it is designed with hardwired control unit. CISC, complex instruction set computer. It uses more number of instructions. More number of, not only instructions, addressing modes also. Instructions and addressing modes. AM means addressing modes. At the same time, it is suitable for real-time applications. Most of the real-time systems. Personal computers are also designed with this one only. In this, it permits more number of addressing modes, but it requires memory visit frequently. That's why it is slower. Memory visit requires frequently means longer time is required to perform memory read or memory write operation, and at the same time, it is designed with microprogram control unit. Next, in IO organization, most important point is DMA and DMA controller. In this, what is DMA? Direct memory access. Direct memory access. Secondary memories are there. Secondary memories, magnetic and optical memories are known as secondary memories. Those are operated with head and motor. Head and motor are operated in millisecond. That's why not possible to communicate such type of devices with the processor. That's why DMA controller is there. This DMA controller is nothing but IC number 8257 IC. It is a DMA controller. It is used to transfer the data between secondary memories and main memory. In this DMA, it is nothing but operation, direct memory access operation. DMA controller is nothing but a device. It is also known as IO processor. So this operation can be performed in 3 ways. What is first one? Burst DMA, also known as continuous DMA. It is used to transfer larger size of data bulk size means larger size of data until completion of entire data transfer. CPU becomes idle. That's why this method is used while transferring larger size only when that file is compulsory required for the system. Next, what about merit? Faster transfer is possible. Demerit, processor becomes idle for longest time, means until completion of transfer. What about next one? Cycle stealing, means in this DMA controller, DMA controller uses bus services when buses are not used by the processor. Means in this, CPU valuable time is not wasted, but it is used to transfer minimum size of data, smallest size data. Maximum 10 bytes like this. It is nothing but application. What about merit of this one? Processor time is not wasted, but it is not suitable for transferring larger size. Cycle stealing means for one clock cycle time, DMA controller steals the bus services when those buses are not used by the processor. Next, what about last one? Interleaved DMA. In this, CPU and DMA controller, DMA controller 8257, it is also known as IO processor, share the bus services. Which bus services? Address bus, data bus, control bus. To perform data transfer, these buses are required. Bus services in alternative clock cycles. This method is used to transfer moderate size of data. What about application? When data size is moderate, thank you very much, and I am thankful to our ACE Engineering Academy for providing this opportunity.